friends, you are welcome to Soft Reason. This lesson will be considering the first method of RCC building design in Staad Pro out of the 3 method of RCC building design. So let's get started. We will go straight away to the model tab. In the drop down menu, select the run structure wizard. Alright, so in the wizard dialog, select under model type, select frame model, then double click on the bar frame. In this provision, you have the length 12 meter. Okay, so we are going to be considering 9 meter length in that direction. Then the number of bar along length is going to be 3. Alright, the height of the structure is 3 meter. Since we are considering 3-story building, we are going to have a height of 9 meter, and then the numbers of bars along height is going to be 3. Alright, just like this, click on apply. So this is what we will be having. Alright, so just click on closed to transfer that to the model interface. Click on yes and okay. So you will have something of this kind. The next thing we are going to be considering is the property. Okay, so click on the general. Alright, so in this general, we are going to be creating property for this. Alright, so we click on the define tab. So in this dialog, we come to the rectangular tab. Okay, we are considering concrete, and then the depth of the column we are going to be considering is 225. Right, 225, just like that, and then the width that makes the section is also 225, just like this. Click on add. All right, so for the beam we are to be considering 225 by 450, so we will having 0.45 right away. Okay, you will add. For the roof beam, we are going to be considering 300 for the roof beam, so we have 0.3, okay, as the depth, and then 225 is the width. So we click on add, closed. Okay, so we are going to be assigning this to the columns, 225 by 225 columns. So select that right away, come to select tab in the drop down menu, beam parallel to y-axis. These are the columns, so we have to use assign to selected member. Click on assign and yes option. That has been assigned successfully. Right, for the beams that is to carry the slab, or the beam that is to bear the wall load, select this one, 450 by 225, and then go to the front view of the navigate to the front view of the model. Align the first, second floor beam, or the control key, so you can be able to align the first floor beam right away. Go to the isometry view, just like this. Okay, then assign to selected beams, assign yes option, just like that. All right, then for this one, we will be considering the beam, the roof beam. So activate that, go to the front view, highlight the roof beam, just like that. Navigate to isometry view and assign to selected beam, assign yes option. Okay, so we will be considering the plate for the slab. All right, so we are going to go to the front view again, highlight the first floor beam, just like this. Right click and then select right click and then select new view. In this new view, click on OK to have that. Go to the isometric, just like this. Click on this generate surface mesh, and then pick the first point, pick the second point, third point, fourth point, and the first point again. Then we are going to use quadrilateral meshing. Click on that. So in these provisions, the divisions we are going to be having, 4 right away in the length A, B, C, and D, just like this. Okay, click on applied. So this has been divided successfully. So you just click on view the whole structure, just like this, and then select the plate cursor, this one, and select all of the plates, just like this. Right click and then copy that, right click and paste that, because we want to have it at the second floor in the y direction. All right, so it's 3 meter. Click on OK, yes option. You can see we are now having the plates right away. So the next thing is the plate thickness. Click right there, plate thickness right away. We'll be having a slab thickness of 1.5, just like this. Okay, it's a concrete. Click on add, right, and close this. Select it and then assign it to view, just like this. So you can now view your structure in 3D. Click these provisions, deselect the selected plate and click that provision, so you have this. All right, close that. You can still check your structure if there is any structure with no property. For you to do that, you just have to come to select right away, come to by missing attributes, and then missing property. As you know, entity with missing property is fine. Click on OK. So we are good to go. Come straight away to the loadings, the supports. Okay, view the structure in these directions, and then create supports, fix support just add that. You can see, select it right away and select the nodes right there, and then assign to the selected node, assign, click on the yes options. Okay, view it in isometric view. All right, the next thing, we'll go to the loadings. Okay, click on load and definitions. In this provision, select this, add. All right, so the first load we're considering is the dead load. Okay, so you give it a name as DL. You add that right away. The live load, LL. Add that right away. The next load is the roof load. Okay, RL. Add that. So these are the load we are going to consider. Close this. Dead load, add. All right, so this is going to be a safe weight, so add that. Okay, for the dead load of the beam, we are going to be considering it to be 10.43. Okay, you have to prefix it with minus. All right, add 10.43 is gotten from the unit weight of block. All right, unit weight of block multiplied by the height of the block, you get this. All right, so add that, then closed. Come to the live load, add. All right, so in this live load, we are going to be considering the floor load, this one. So the first live load we are going to be considered is minus 1.5. This minus 1.5 is gotten from the structural use of the building, the purpose of the building. All right, so it's going to range between 2 to 8 meters because the building is 9 meters altogether. So the slab is between this range, 2 to 8. All right, so we are going to be applying this pressure to the slab because this is assumed to be a residential structure and the live load is 1.5. Add that. The next live load we are going to be considering is the self weight of the slab, which consists of the thickness of the slab multiplied by the density of concrete. The thickness of the slab is 0.15 multiplied by 24, which is the density of concrete. You have 3.6, just like this. So within this range too, we are going to add that. Closed. Okay, for the roof load, select right there, add, and then we are going to be using a member load, and we consider that to be minus 2, which is our roof load in the global y direction. Add. All right, select this self weight and then assign it to view. So select assign to view and then click on assign and yes option. Then for this wall load, select it right away. Okay, select it again, view the structure in front view of it. So the load is, these beams are going to be carrying the wall load. So you select that beam right away, hold the control key so you can be able to select this other beam. You can view it isometry, you can see, then click on assign to selected beam and click on assign and yes options, just like this. All right, for the live load, it has been assigned already, you can see automatically. All right, the self weight of the slab and the structural use of the building. All right, so for the roof load, select that load and navigate to the front view, select the roof beam. All right, activate isometric view, assign it to the selected beam, assign and yes option, just like this. So we have successfully loaded this structure. For the loading combination, you just have to select load case 6 detail and add. So in these provisions, what we need to do is we are going to define load combination. So click on that, select the dead load, add, select the live load, add, select the roof load and add as well. Then for the factors, we are going to have 1.4 right away and 1.6. This one is going to be 1 for the roof load. Okay, click on add, close that. So all of this has been added successfully. The next thing we need to do right away is come to material and update the program. Select concrete, assign to view, assign and yes option. Then the next thing is to analyze the structure. Select analysis and print, add. Okay, click on the analysis tab right away, run analysis at first, save the structure. We are analyzing the structure for 0 error. So we have only one note and 0 error, 0 warning. Okay, go to post processing, click on done. In this provision, bring all of the content. This So we select the load combination for bring it, because that is the one we are going to be using for the structural design. So come straight away to result view, and then activate enable automatic scaling and then bending, and click on apply and okay. So here we have this is the deflections of the structure. All right, so through this now you can now change your check your bending moments. Click right away. So this is your bending moment diagram. All right, it's your bending moment diagram. Okay, so you can also check your shear force diagram. All right, so this is it. Okay, for the reactions you can come to report right away and then click on view report, activate reaction. Okay, in the y directions, annotate. So these are the reactions, okay, for the foundation design. All right, you can also check your movement in the x and z direction as well. Click on closed. All right, so having done this and having checked all of that, we will proceed back to the modeling tab so we can do the design. Okay, the first method of design using Staad Pro. Okay, click on the modeling tab, then come over to design, select right away design. Okay, and select concrete at first. Having that select, come over to the right hand side of the program. Current code, select in the drop down menu. We are going to be considering BS8110. Okay, so select that code. For the parameter selections, click on these provisions and move all the parameters to the left provision. Okay, the first parameter we have to be considering is the clear distance, okay, which is the concrete cover. Select that, take it to the right. Okay, and then the compressive strength of concrete, take it also to the right. The use strength of concrete, the main reinforcement, and as well as the shear reinforcement, take them there, right there. Click on OK. Then to define the parameter, click right away. For the clear distance or the concrete cover, we have to be considering 25 millimeter, just like this ad. All right, so for the compressive strength of concrete, we have to be considering 16,000. So we will input in 1630. Okay, add. All right, the main reinforcement, okay, the use strength, we have to be considering 410,000. So 41000. Okay, add that. For the shear, the same thing, 0000. Okay, add just like this. So after having done this, what we need to do is we are going to assign this to the structure. Select this one, select assign to view, assign yes option. This other one, assign to view, assign yes option. Assign to view, okay, assign yes option. Assign to view, assign yes options. So after which we come to commands. You will select this command. Okay, design beam, add. Design concrete, add. Take off, add, and close. Navigate to the commands, design beam. You go straight away to select, and then under beam parallel to x axis, select again, beam parallel to z direction, select, and these are all the beams in this structure. So we assigned beam design to that. Okay, so select assign to selected beam, assign yes option. For columns, the same thing. Come to these provisions and then beam parallel to the y directions, just like that, and then assign to selected beam, assign yes option. So after which you will go back to concrete again, select that, and in the current code you change the code to BS8007. all right, come to the select parameter, bring all what is in the right to the left. For the concrete cover, you take that, you use compressive strength of concrete, take that to the right, and as well as the use strength of main reinforcement, just like this. Click on OK. Define it just the same way, 0.025, which is the concrete cover. Add. Okay, the compressive strength of concrete is going to be 16,000. Alright, add. Okay, so the use strength for main reinforcement is going to be 410,000. And then you add. Close this. Navigate to these provisions, add command, beam, add, column, add, take off, add, close that, scroll down, so you can assign this, assign to view, assign yes option, select that, assign to view, assign yes option, select this, assign to view, assign yes option, select this, go straight away to select, and then in the drop down menu, X directions, get those beams selected, again Z directions, then assign to selected beam, assign yes option, columns, select again, tap in the drop down menu, beam in the Y directions, assign to selected beam, assign yes option. So after you must have done all of this, what you now need to do is to carry out analysis again. So you click on analysis, add, and select analysis, run analysis again, save the project. We are going to check for zero error. So analysis is successful. So we are having zero error. Go to the post processing, click on done. All right, so this has been analyzed and designed successfully. So we want to check the reinforcement. We are going to activate the beam cursor, this one, double click on the roof beam. So here we have this dialog, select on design, so you can see now beam number 7, design code BS8110. Okay, we are having four 8mm bar, okay, top and bottom for the roof beam. So you can see, so you click on closed. Okay, for the second floor beam, you double click right there, go to concrete design. So you're having 5 8mm bar, okay, you can see this is beam number 110. It is top and bottom. All right, click on closed. For the columns, you double click on the columns, come to concrete design. You can see we are having 4 white wave. Okay, this is the area of steel. Okay, the number is 4. Right, click on closed. If you want to also print the output or check the analysis results based on the design, you can click on this provision, start output. So in this output design, click on the result. So you select this beam, you scroll down, right away you can see beam number 1 design result. Okay, you can see the length and the property as well. Okay, the bar informations, the height, provision for the shear links as below, you can see. So if you check this down, you will see all of that has been designed successfully. So this is the first method that you can use to design reinforced concrete members using Staad Pro. In the next lesson, we'll be looking at the second method, and subsequently we'll consider the third method using RCC. Once again, you are welcome. We bring the lesson to a stop here. Stay tuned for more advanced lesson of this kind. Bye for now.